welcome. Welcome to part 2 of control statements. We already went over part 1. If you haven't watched that, this is the second half of that first video. If you haven't watched it, please take the time to watch that as we go over part 2. So let me go ahead and not do that. All right, here we go. So in this chapter, we're going to learn about the essentials of counter-controlled repetition. We're going to learn about the use of for and do while repetition statements. We're also going to learn about switch multiple selection statements, as well as break and continue statements to alter the flow of control inside of your statements. We're also going to go over the use of logical operators and how to form complex conditional expressions using them. Okay, so counter-controlled repetition requires a couple of things. First, it requires a control variable, or a loop counter. Secondly, it requires an initial value of the control variable, meaning that it requires you to have initialized the counter or the control variable you're going to use within the counter. Then you need a decrement or decrement, not excrement. That's what happens when you use the restroom, but increment and decrement, by which the control variable is modified, meaning that the loop knows when to begin and when to end, and a loop continuation condition, so that the loop knows when to end. So these two kind of help the loop understand it's time to stop. And here we go. Here's a while loop that has a condition that says, while the counter is less than or equal to 10, do some stuff. And it initializes the counter as an integer and assigns the value of 1 to the counter. So in this case, while the counter is less than or equal to 10, print the counter value, and then keep looping until counter equals 10. So this should count down count up 1, 2, 3, 4, 5. In order to count down, the counter has to be minus counter. Because floating point values may be appropriate, controlling loops with floating point variables may result in imprecise counter values and inaccurate termination tests. All this means is that floating point uses decimals, and you don't want to use decimals when you're doing counts. You don't want to go 1, 1.1, 1.2, 1.3. You want to go 1, 2, 3. So in order to do that, we only use integers when we're using counting loops or iterative variables. Counting loops just, it sounds weird. Iterative variables, excuse me. So yeah, my braces, making it hard to speak. Alright, so the app can be made more concise by initializing counter to 0 in line 9 and incrementing the counter in the while condition. So while, and you can increment the counter in the condition, is less than 10, denote the counter. Keep it simple. So we all know the KISS acronym. Keep it simple, stupid. And in this case, what you want to do is you want to keep most of your code as simple as you possibly can. The more complex you make your code, the harder it is for your code to actually do things. Or the more complex your code is, the more complex it is to troubleshoot, I should say. So for repetition statements, a for repetition statement specifies the elements of counter-controlled repetition in a single line of code. And if we look at figure 6.2, it will show us what a for statement actually does. But what I want to do is, before we go there, I want to kind of go over it myself. So we went over while loops, and while loops are nice, but for loops are nicer. And the reason why is because for loops encapsulate everything you actually need the loop to do. So let's write a for loop for shiggles. So for, and let's initialize. So there's 3 specific overloads you want to add to your for loop. It's going to be the variable that is the counter, and you have to assign a value to that counter, or iterative variable if you want to call it such. It also needs to know how long the iterations are for. So it needs to know when to begin, it needs to know when to end, and it needs to know what to do to the counter. So in this case, if you want to go with your regular expression, the way we normally use I as the iterative loop. or the iterative variable. So we're going to initialize the variable I, and we're going to initialize it to the value of 0. Then I'm going to say I, or while, you can use the word while here, but I is less than or equal to, and normally, if you want to do if you want to loop through an array, you would say array.length. Now, I don't have an array, so let's make one. And let's initialize some values to the array. That's not correct. Let's do string array. Oh dearie. All right, there we go. And we'll say sArray equals new array. And we will add some properties to this array, or elements, I should say. And we'll say that we're gonna add. Oh, geez, I can't type today. What is going on? All right, we're gonna add my name. We're gonna add another. We'll just say Jacob, and then Jeremy. Now, what I'm essentially doing right now is I'm adding elements to the array, and it doesn't like it, so I'm guessing my syntax is incorrect. Maybe if I did that, if I can type. There. And then new string array. I should have said new string array. If I do that, does that work? No, it doesn't. Maybe I'm supposed to. Give me 1 second. Like that. Give me a second to look this up. I'm doing it right. I'm just not doing it right. Okay, I got it. Figured it out. So it should be like that. Got it. All right, so we have a string array. And in the string array, I added a few elements. So Francis is at, well, we'll name it John to keep it all symmetric, right? So John's at the 0th position, Jacob's at the 1st position, and Jeremy's at the 2nd position. All right. So in this case, I initialized an array and I added elements to that array. Now in C#, when you initialize an array, you have to initialize the array's data type. When you do that, you can only add that specific data type to the array. So if I decided I wanted to add an integer to the array, it would kind of crap on me because it doesn't like that. And it just did. Good. And it will say that I can't add int to a string, or I can't convert the int to a string. And that's true, I can't. So let's go ahead and get rid of that. Let's keep it all at names or strings. And let's say while, and what this second parameter here does or says is while I, minimize that, while I is less than or equal to, now I could say 3 or 2, I'm sorry, and it will stop. But what if I don't know how many positions are in the array? Now that's rare in C# because you have to tell it how many positions there should be. But let's say it's like a list. You don't have to necessarily tell C# how big a list is. You can just say new list and add whatever you want to it, right? A list is a type of array that is dynamic in C#. So in this case, I could say sArray.length. Now what does that do? Length is a parameter of an array. Length is also the parameter of a list. And what length actually means is that it's asking the program to tell it how many elements exist in that array. That's what length is. So, and then I'm going to say I++. And what that means is increment I by 1 every iteration, after every iteration. So in this case, all I really want to do is print this array. So I'm going to print what the internals of the array are. If I don't dork this up too hard, there we go. And we're going to say sArray I. Wonderbar. And I really don't need the rest of this right now. I'm just going to get rid of it or comment it out for now. I don't know if I'm going to need it later. All right, so let's go over what this says to do. String array is the data type of the array that we just initialized. New string, or new, means build the array and add that assign that to this array name, if you will. And then I added some elements here. You don't have to do this, but I did it inherently anyway because it's just easier. And then I created my for loop. So in the for loop, I have the counter here, var I equals 0. You can name this whatever you want. It doesn't have to be I. It can be index. It can be anything. You can name it whatever you want. Really, it's just a variable name. But we always name it I, sometimes J, depending on the instance. But I is the easiest. I index. That's really what it stands for. And then the next parameter here, I equals, or I, whatever this second parameter does, is it says when this condition is met, stop. So while I is less than or equal to sArray.length, which is, if you can see there, I'm scrolling over and it's giving me the IntelliSense, get the total number of elements in all the dimensions of the array, which means that it's going to count how many elements are in the array and give me back a number. So in this case, it'll give me back the number 2. 0, 1, 2. And so while I is less than or equal to however many elements are in the array, which are 2, because we always start at 0. And then I plus plus, which means increment by I. And then inside the for loop, I made it do some things. I'm going to show you something else after this to kind of get you thinking a little deeper into the weeds, but let's go over this really fast. So I'm going to start this, and then I'm going to stop it because I just realized, oh, there it is, cool. Oh, I got an error. Index was outside the bounds of the array. That's interesting. Why did I get that? Oh, because it ran one more time. Well, that's interesting. But I did get something. And what did I get? I got the elements of the array. Now, there's something you need to know about if you want to print or get what's in the array, if you want it to display or anything like that, you can't just say console.writeLineArray. It won't work. It'll return an array list. Literally, it'll say array list. Now, I don't know if that's changed, but for the longest time, that's what it did. It'll tell you the type, or it'll tell you the control statement. It'll tell you the control that it exists in. In order to print what's in the array, you have to iterate through it. Well, let's take this a step further. Let's make this a real-world object, because in this case, I actually wouldn't really use an array. What I would actually use is a list. So let's make a list, shall we? In order to make a list, all you do is say list. Now, you could also have a model for the list. So let's go ahead and do that. Yes, I know this is a bit outside the scope of this chapter, but let's just do it for shiggles. Stop. Thank you. All right, we're going to leave this here for now, and let's go make a model. All right, we're going to call it model person, and I'll explain to you what that actually is in a second. So class, and we're going to call this person record. Or we'll just call it person. Now, what makes a model a model? As a matter of fact, what I'm actually going to do is I'm going to make a folder as well because I like all my stuff to be nice and compartmentalized. So put that in the... I hope I grabbed the wrong thing. Yeah, I didn't. I grabbed program. I don't want that. So grab model, or grab person, throw it in the model. So what's a model? Well, a model is part of your MVC framework. A model, view, and controller is a framework that's deployed by now .NET Core. It used to be .NET Framework. It's a specific way of developing. And what you essentially do is, remember a couple of sessions ago, and I don't think I have that class anymore. I think that's in another, I do, Gradebook. So remember in Gradebook, we created this property? Well, this is a form of a model, but it's not. And the reason why it's not is because you have to pull in other things. What a model actually does, it basically is a class that is just a compilation of properties, and those properties are congruent to one another. So in this person class, I'm going to create a model with nothing but properties, and I'm going to call this model whenever I need to create a specific person. I'll explain. So, what makes a person a person? Well, first, we'll say that a person needs a name. So, last name. Well, we'll say first name. And as always, with a property, you have to get set. Then, what else does a person need? It needs a last name. Get set. What else does a person need? We'll say public string gender. Get set. What else makes a person a person? Let me see. You know what? At this point, I think that's good enough, because we're not going to go too far. Now, the reason why we do this is because you want like properties to be in like classes. Remember that when we develop, we want to make sure that everything that we are developing is in the right order. So what I'm doing right now is I'm making a class that will ensure that the data that I want is in a specific format. So let's invoke this class. Let's use this class. So class person, right? I want to make a list. Now I can just make any old list if I wanted. I can say list or lists and then say new list. And it would kind of not understand what I want. Now the reason why is because when you make a list, you also need to call what's called the T. You need to call what the list should have as parameters or as properties. So how would I do that? Well, I just created a class called person that contains all the properties that I want to use. A person needs a last name, first name, a person needs a last name, a person needs a gender. Of course, a person needs a lot of other things, but we're not going to go that deep into it. We're just going to create a model that contains 3 properties. All right, let's go back to the program and let's create this list. But instead of creating a list without a model assigned to it, let's assign a model to it. Person. Now, what did I just do there? Well, I took the class person and I added it as a parameter to list. So now, if I want to look in persons and I want to add a person's last name, how would I do that? Like so. I can say person. How do I do this? Person equals new person. I don't like doing that, but I'm gonna do it now. And now what I'm gonna do is I'm gonna add the new person. And well, I'm gonna create the new person's properties. So I created a concretion, or I instantiated the class person, right? So now when I call the class person from this class person, I now have here in the form of the variable person. Okay? As a matter of fact, I can name this anything. I can say new person. How about that? So it's not as confusing. Now what I can do is I can add new person properties to this actual person. New person. You see that? Now I'm getting all the properties that are in the person class. So let's add a first name. Jacob. Let's add last name. Let's add a last name. Anderson. Oh, that's not true. You don't do it that way. You do it with commas. Oh man, I'm losing. There you go. And now I'm going to add new person dot gender, and we'll say that he's male. Now, what is it crying about? Invalid initializer declaration declarator. That's interesting. Why is it doing that? Let's check this error to see why. It's something I'm missing. Very simple, actually. So, valid. I'm probably just not thinking straight right now. That should have worked, actually. Because I just did this not too long ago. Or maybe it didn't like the fact that I didn't call model into the pro. It shouldn't have mattered because it likes person just fine. That's interesting. I think I googled the wrong thing. There it is. Yeah, I did it right. That's interesting. Alright, well, I mean, I don't have to do it this way. I can do it a different way, but I don't want to. Yeah, but that doesn't really work. It's not what I wanted to do. Because what I want to do is I want to take this new person and I want to add... Wait a minute. Wait a minute. No, that's not right either. What am I doing wrong? I literally just did this yesterday. I mean, theoretically speaking, I don't have to do it this way. I can just go... Boop. Oh, man, I am just the greatest at making mistakes. There. Alright. I already called new person. I don't even know why I just... Wow, okay. I wasn't thinking straight there. So let's add a couple of persons, right? So we'll say person Jacob. We'll say person John equals new person. And then we'll add properties for John. First name equals John. Last name equals Doe. Gender equals male. We'll add one more person Susie equals new person. And then we'll add some parameters for Susie. First name equals Susie. Now, obviously, this is not the way you would add data to your model, but this is just for right now. Last name equals Johnson. Now, let's make a new alliteration. Smith. Gender equals female. Excuse me. Okay, so now let's add all of these persons to our list. So, it's just as easy as saying add. So, literally, we can say persons.add. I can also say add range, but in this case, I don't really have a range to add. So, we're just going to add, and we're going to add Jacob. We're also going to add, or we can do it at the end, so it's easily readable. So, now we're going to add our persons to our list. So add Jacob, add John, add Susie. So let's go back over what I just did. So a list is a form of a data structure. It's like an array, but you can add and remove whatever you want from the list. Now what makes a list powerful is you can tell the list what you want it to be without actually saying list be this. You can create a class or a subclass, partial class, if you will, with the properties you want to use. All this is a blueprint. Nothing's being stored in this class. You're just telling the model what you want it to be like, or how you want it to operate, how you want it to act. So in this case, I said I want the list to contain the properties that are in the class person. I then gave it a name. This is the name of the list that I want, and I said be a new list. Now I added a bunch of people or persons to the list. So person Jacob equals new person, and I gave it some properties. John, I gave him some properties, and Susie, I gave her some properties. I guess I can make it even and do one more. Emily equals new person, First name equals Emily. Not this name. Last name equals last name Sanders. Gender F. Okay. And then semicolon for good measure. And then I'm going to add all these. So persons dot add Emily. Cool. So now all of these persons should be added to the persons list with the properties that that we've given to them. Now, obviously, you wouldn't do it like this. You'd take these properties and do it in another class, but I'm just going to do it here for the sake of time. Now, what I want to do is I want to iterate through this list and get the properties that are displayed here. But I wouldn't use a for loop to do that because that's just asinine. So what I would do instead is I would use something called a for each loop. Now, what does a for each loop do? A for each loop, for the most part, looks at the array, determines how big the array is or the length of the array, and it iterates as long as there's something in the array. Once there's nothing left in that array or that decision structure like an array as in a list, it'll stop iterating. And this is what a for each loop kind of looks like. For each, and I'm going to talk through the way this is going to iterate. So I need to ensure that the class, model, whatever you want to call it, person is the data type. This person is the data type that we created in this model. All right. And then what we did was we took this data type and said, okay, I want all these variables and I want all this list to be of type person. Okay. Now let's iterate through it. So for each person, and I would say person, in persons, because that's the name of our list, persons. So what I'm saying is each data type person, variable name person, in the list persons, I want you to do the following. I want you to console.writeLine what's in it. And what I want you to write is first name or last name. Try again, please. There we go. Last name, semicolon, first name. And we'll say gender. All right, cool. And then we'll say person dot last name, person dot first name, person dot gender. And that's that. Now, there are certain situations where this will give you an error that says, oh, this is not IEnumerable, whatever. What IEnumerable means, it's an interface that C# uses that allows you to loop through a specific list. There's also an interface called iQueryable. And what iQueryable does is it lets you run SQL queries on your list. Yes, you can do that. You can treat your list like a SQL table and then run SQL link queries off that list. It's very powerful, actually. We do it a lot in the real world because it makes it easier to sort through a list or filter through a list or whatever the case may be. And I think I'll go over that in another chat. But in this case, we're just talking about a list. So if I wanted to make it IEnumerable, which is interface enumerable, that's how I would do it. And it really doesn't change much. Oh, an IEnumerable has a specific class associated with, or not a class, but a, what do you call it? It has a specific namespace associated with it. And I'm not calling it, so I'm just going to not do that. I do have the link. But I don't think that's it. I think there's another one that I'm missing, but I'm not going to play with that right now. So one more time before we run this, let's go over what we're doing. So we created a list, which is like an array, called list. We then created what properties we want the list to contain. And we named that class person. And we gave it some properties, right? These are the same properties that we put inside the other classes that we've been using. But in this case, that's all that's in this class, properties. Then what we did was, we said, I want this list to contain the properties of the model person. Then I want to name this list persons. And then I want to use the new moniker, or the new delimiter, to create the list. And then what I want to do is I want to create it based on the parameters that I already gave it. So create new list with the model person. Then I added a couple of persons to the list based on the properties that we gave the list with the model person. So now I can add person Jacob new person, and then I can say I want this to be in the list, I want that to, or I want these persons to be created. But being created isn't the only thing. I also have to add these persons to the list. So I did that here. Persons.add, and I took Jacob and I added it to the persons list. I did the same thing with the last three. Now I want to print out what's in the list. So what I'm said here is for each. Remember what a for each loop is. It's a for loop, but I don't have to write an iterator. I don't have to write an iterative variable like I or j. I don't have to define how big the array is or the list, and I don't need an increment. All I need to do is give it the array, in this case persons, and I need to tell it what to drop each specific person or element if you look at an array. So element's got element in the 0th position, 1st position, 2nd position. It's going to iterate through, look at the 0th position of the list, and place whatever properties are there, in this case Jacob. It's going to place Jacob in this person variable. Now I can call that person variable whenever I want to use it. As a matter of fact, I could probably make this a little more easier, because person is actually something else that we use. So it doesn't matter, but just so it's not as confusing. So for each element that's in the list persons, I want you to place it one by one into this variable. And now I can call that variable in the array. And I should actually get all the persons without error. Let's see what happens. It went away. So let's do this. And let's run it. And what do I get? I got all the individuals that are in the list. And at console.writeLine, which lets me know that it ran. That's how a for each loop works. Normally this is what we use in the real world. For loops they're good, they're fast, but having to write it all out like that is just a pain. For each does all the work for you. But the for each loop pretty much did the same thing that the for loop does. Let me show you what this would look like if it was a for loop. So instead of for each, we'll comment that out. We'll call it a for loop. So for I, var I equals 0, while I is less than or equal to the person's dot length. Ooh, would you look at that? There is no length for list. So how would I know how big the list is? I guess it's time for some investigations. List for loop length. Oh no, list length. That's what I want to know. And I don't normally do it this way. So it's not length, it's count. Count will give me the size of the list. And then I want to iterate, I want to increment the I by 1 each time the iteration runs. So now I can't do this. Now I can't say parse person record.lastname because person record doesn't exist. Remember, we created this variable here, and we could have just called the variable because that variable is what each of the persons is being added to. But in this case, that's not what's happening. So now I have to change it. I can't say person record.lastname. What I have to say is what I want it to do. So for each person in the persons list, I would say person. Let's see if it'll let me do this. I will. So what I have to do is I have to index persons like it's an array. Now what is that going to do? What it's going to do is it's going to look at persons, this list right here. It's going to look at the list persons. It's then going to take the value of the counter or the value of the iterative variable and place it here. I is the integer that we're going to use here. So when it iterates the first time, I is going to be 0. When it iterates the second time, I is going to be 1. And what that does is it treats the list like an array. And it will look in the 0th position for the last name. It'll look in the 0th position for the first name. It'll look in the 0th position for the gender in the list persons. It'll then print that, and then I will increment 1 time. And then now it's persons 1.lastname, persons 1.firstname, persons 1.gender. It's going to print that. It's going to increment again, and so on and so forth until the amount of elements that's contained in the list has been satisfied. Let's see if this works. And would you look at that? It did the exact same thing that the for each loop did with an error because I'm not paying attention to index size. As a matter of fact, I should probably do this differently. I should probably do it. I thought I stopped you. I did not. I should probably say increment after the I. Save. Go. Now, I'm just going to have to figure that one out. But here we go. Jacob Anderson, John Doe, Susie Smith, Emily Sanders. It all works with an index error, but that's irrelevant. It's not going to be in production, so I really don't care about this error. It doesn't really do anything but tell me that the index that I passed again to it doesn't exist. So basically, it passed 0, it passed 1, it passed 2, it passed... tried to pass 3. I shouldn't have said less than or equal to. Oh, that's the problem. Man, it's... oh, no, don't do it again. I should have said less than, and then I won't get that index error. Yep, there you go. No index error. Because less than or equal to means that it'll index past how large the list is. The list is only 2 elements large. 0, 1, 2. I'm telling it, okay, now I want the third, I want the fourth, or I want the element in the third position, but there is no element in the third position, so it says non-index, there's nothing there. It happens. But that's why I should say I is less than persons.count. But either way, here it all is. It's the same thing as a for each loop. For larger lists and whatnot, I guess there's an argument to be made for using the for statement instead of the for each. But in the end, for each is just easier to write. You can see that there's a lot of stuff we have to write in here that we didn't have to write in for the for each. For the for each, it was really simple. It was just person, record, and persons. And then I didn't need the I because it was inherent. It knew what to do. Alright, so I went off the reservation for a second there, and that was actually a lot longer than I thought it would be. But I think it was worth it. So let's jump back in real quick. And I think I kind of went over a lot of what we're going to go over today. Plus this part, which is... I wanted to show you what it actually would look like in real life. This is actually how you would actually do it in real life with a list. You wouldn't use an array. But c'est la vie. So let's go over it. And here's the for loop. This is how we wrote it. It's pretty much the same thing. You can do counter plus plus. You can do plus plus counter. It just all depends on how you want the counter to iterate. But it's pretty much the same. For int, which is the data type of the counter or the index, we initialize the index. We then say this is when we want the for loop to stop. So counter is less than or equal to 10. Notice that I started at 0, right? I always start at 0. When you start at 0, it's not less than or equal to, it's just less than or greater than. If you do less than or equal to, you're going to get an error like I did. You're going to get an index error of some kind if you're trying to index, if you're trying to loop through like an array. Normally for loops are for arrays. That's normally what we use loops for. Using the final value in the condition of a while or for statement with the less than or equal to relational operator helps avoid off by 1 errors. And it does. But if you start at 0, this doesn't matter. So always start at 0. In computer science, discrete mathematics forces us to start at 0. Always start at 0. Don't start at 1. 1 is not the beginning of numerics in computer science. 0 is. So this is kind of like a taboo. Always start at 0. So int counter equals 1, but like I said, you always start at 0, which means that the counter will be less than 10, not less than or equal to. The reason why that is because you're going to reach 10 and then you're going to stop. If you did it at 1, then you would need less than or equal to. But if you always start at 0, you don't need the less than or equal to. You just need less than. So, in most cases, the for statement usually can be represented with an equivalent while statement, and that is true. But while statements, like I showed you in our example, the for statement was a bit beefy in comparison to the for each. Well, the while statement is equally beefy. So take that with a grain of salt. Notice that you have to create your own increment. You have to create your own condition. It's just a pain. So if you need to write a while loop, you're probably better off writing a for loop. And if you need to write a for loop, then you're probably better off writing a for each. But it all depends on what you're trying to do. If you're just trying to loop through whatever the user's doing, then yeah, I guess a while loop's not a bad idea. But normally you wouldn't do that. So... oh, and for the record, you want to avoid loops at all costs. Loops are a drain on your CPU, and on your RAM, you just want to try your best not to use loops. Loops should not be your first choice. But there are situations where you need to loop through data, and it's just easier to loop through it, so you do. A lot of developers take for granted the CPU cycles that they have nowadays. When I was developing back even 10 years ago, CPU cycles were precious. And so what you didn't do is you didn't just create for loops all willy-nilly wherever you wanted them to be. And if you talk to a lot of SQL developers, they'll tell you that they hate cursors for the mere fact that those loops can destroy, well, can bring down, your servers can pretty much catch on fire if you do it incorrectly. So if you're looping through millions and millions of records, I know it sounds like I'm exaggerating, but it can be done. So this restriction is known as the variable scope. So if the initialization expression declares the control variable, meaning that the control variable is being declared in your for loop parameters, the control variable will not exist outside the for statement. And that is true. If you initialize your variable in any function's parameters, it will not be accessible outside of the program, outside of that method. What does that mean? This I right here, for I, we initialize the variable I. But I is not accessible outside of the for loop. If I try to use it again outside the for loop, it doesn't know what I'm talking about. See, it tried to change it to if. Do you really mean if? No, I meant I. But I doesn't, outside of these brackets, I does not matter for much. When a for statement's control variable is declared in the initialization section of the for's header, using the control variable after the for's body is a compilation error, and I just showed you that. In most cases, Visual Studio will not allow you to do it. All three expressions in a for header are optional. This is true. But if you want the for loop to work the way that you anticipate it working, please fill all of the parameters. And as I spoke earlier, the var I equals 0 is the loop continuation condition. It's the initialization. The loop continuation condition, or the while I is less than the persons.count, while I is less than array.length, and then the increment. You can omit all this stuff. Don't do it. Just write your for loop with all three of them. You're going to need them at some point in time. There's a slight performance advantage to using the prefix increment operator, but if you choose the postfix increment operator because it seems more natural, as in a for header, optimizing compilers regenerate code that uses the more efficient form anyway. So it really doesn't matter how you write your increments, whether it's ++ before the variable or ++ after the variable. The compiler will change your code to be the most efficient. Now, it won't change your for loop to a for each, but it will try to make the code that it does understand better. Infinite loops occur when the loop continuation condition in a repetition statement never becomes false. What does that mean? Let's create a for loop that is an infinite loop, but let's not run it. There. I just created an infinite loop. Now, why is it infinite? Will I ever be greater? Actually, no, this is not infinite. I'm sorry. Let's say I need to create can't do that. It's actually not very easy to create an infinite loop, but you can do it, and I'm trying to think about how I would do that here. There. I just made an infinite loop. Why? So, var I equals 0, meaning that the index is initialized to the data point 0. While I is less than persons.count minus I. Will I ever be greater than persons.count? No, it will not. The reason why is because I have my increment or my decrement going down, not up. So I will never reach however big persons.count is. And so it'll never finish. This is called an infinite loop, and this can be a problem when you're making code that goes into a production environment that can bring down servers, bring down services, or bring down whatever the case may be. I'm not going to execute this because I don't want my box to just blow up, but you want to create for loops that end, which is why for each loops are so nice, because I really don't care. Once there's nothing left in the list persons, the for loop ends. I don't have to tell it to. So this kind of takes the headache out of making sure that you don't create infinite loops. So, although the value of the control variable can be changed in the body of a for loop, avoid doing so, because this can lead to subtle errors. So the initialization, loop continuation condition, and increment portions of a for statement can contain arithmetic expressions. For example, assume that x equals 2 and y equals 10. If x and y are not modified in the body of the loop, then the statement for int j equals x, while j is less than or equal to 4, times x, which is 2, times y, which is 10, which makes this 80, because 4 times 2 times 10 is 80. J equals j plus y divided by x. This is a very complex problem, but either way, it's saying j is increment by 5. If the loop continuation condition is initially false, the app does not execute for the statement's body. So when this condition is met, then the app will not run the for statement. That was a bit complex, and a bit interestingly enough, it didn't need that type of complexity, but their point is made. If this condition is proven false on the onset of the for loop being run, the body of the for loop will never run. And here's a UML diagram of what a for loop or for statement looks like. So you initialize the control variable, in this case the counter, which is I, and then there's a decision here. The decision is whatever you make that decision to be, whether it's I is less than or equal to the array length or the list counter or a specific value. And then you increment or decrement. You don't have to necessarily increment it. You can decrement as well. You can say, j equals 10, and then you can say j minus minus, and it'll count down. You can say while j is greater than 0. And then what'll happen is this 10 will wind down to 0 eventually, and then boom, the loop will end. And once the loop ends, it'll do something along these lines. So use the for statement to sum even integers from 2 to 20 and store the result in an integer variable called total. Not using the proper relational operator in the loop continuation condition of a loop that counts downwards, and we just talked about counting downwards, did we not? Using I is less than or equal to 1 instead of I is greater than or equal to 1 in a loop counting down to 1 is a logic error. Remember, logic errors don't necessarily throw actual errors, but this is more than a logic error. It's a infinite loop, because the program will never reach this condition. Or actually, it'll never run, actually. So, int number equals 2, so the integer number is the condition. I'm sorry, number is the counter. Number is less than or equal to 20, so that's the condition. And then I want you to number equals number plus 2. So after the first iteration does its thing, number will then equal 4. When it iterates again, number will then equal 6. When it iterates again, number will then equal 8, and so on and so forth. And there you go. Sum is total, and then it'll print it out. So the sum is 110. But total plus or equals number. The initialization and increment expressions can be comma-separated lists that enable you to use multiple initialization expressions or multiple increment expressions. In this case, you can add more than one expression to the increment, and you can add more than one expression to the initializer to get a specific value. Alright, so consider the following problem. A person invests $1,000 in a savings account yielding 5% interest, compounded yearly. So a dividends algorithm. Calculate and display the amount of money in the account at the end of each year for 10 years. This is the algorithm for dividends. A, which is the amount, equals principal, and then in parentheses 1 plus the annual interest rate, to the power of the number of years that the money will be invested. In this case, we're going to use 5% as the annual interest rate. Our principal is $1,000, so P is 1,000, R is 0.05 for 5%. If you ever want to find out what percent is, you just do the value of percent times 0.01, and you'll get the percentage in decimal points. And then N obviously is 10 because that's how many years that the money is going to be invested. And this is how you would write it. So you have the decimal amount, the principal amount, and the actual interest rate. And what it does is it prints the amount on deposit, and then it does the work. So it tells you each year what your investment will accrue. So in this case, we initialized the counter as year, starting at year 1. We then have a condition for the for loop to end. While year is less than or equal to 10, increment the year. In this case, there's an actual power of math function that we can use. So in this case, power of 1.0 plus rate, and then the year. And the power of is actually the function that you saw before with the parentheses and n. Well, n is this math power of. So amount equals principal, P, times, and you have the power of, so 1 plus rate, and then the year, which is this. And print it out. And these are the answers that you would get. I'm not going to write it out, but these are the answers that you would get from doing that for statement, that for loop. We use the format 020 to input the string amount on deposit. The integer 20 after the comma indicates that the value output should be displayed with a field width of 20. That is, right line displays the value with at least 20 character positions. If the value to be output is less than 20 character positions wide, the value is right justified, meaning that it'll look like that rather than being centered or left justified, meaning that the values will begin on this side of the screen. If the value to be output were more than 4 character positions wide, the field width would be extended to the right to accommodate the entire value. Many classes provide static methods that cannot be called on objects. They must be called using a class name. You can call a static method by specifying the class name, followed by the member access operator and the method name. This is an older way of doing it, but if you want to call a method, you need to create it, give it a static moniker. Now, what does that mean? Let's go back to our code here, and let's look at. I don't think I have a static variable. I'm sorry, a static method. Well, actually, no, I do have the static method. In this case, if I just wanted to call the method directly from the class and not instantiate the class, I would have to say gradebook dot. There's nothing there because gradebook has no static methods. If I wanted a static method, I need to come in here and say, where is it? Public static void. Now I can call that method. It should be available to me now. So dot display message is now available to me, and I don't have to instantiate I don't have to instantiate the class to get the method because it's static. but I also can't use the method when I instantiate the class. It's no longer available to this variable anymore because it's not a part of the class, yet it is a part of the class. It's a bit complicated, but for the most part, you want to try not to do that. I use static methods when I need to use a method, but I don't want to have a concrete, or this is called the concretion. I don't want to instantiate the entire class. I just need that method. Console methods write and writeLine are static, meaning you can call them whenever you need to, and you don't need to instantiate the console class. Do not use variables of type double or float to perform precise monetary calculations. Use type decimal instead. In loops, avoid calculations for which the result never changes. Such calculations should typically be placed before the loop. Optimizing compilers will typically place such calculations outside loops in the compiled code. The do-while repetition statement is similar to the while. Now, I'm going to go over this very quickly, and there's really not much of a difference. In a do-while, or in a while loop, the condition is asked for first. So this is the condition. Then it runs the code. And every time it loops back, it asks for the condition first, and then runs the code. In a do-while loop, you execute the code first. So here's the code segment. It'll execute without any sentinel or any condition. And then at the end of the while, or the do-while, or the do loop, it'll ask for the condition. So it'll look something like this. Do x, x will do its thing, and then it'll say while x is not equal to, or less than or equal to 10, do it again. And then it will ask for the condition after, not before. So in the while loop, the condition is asked for first, then the code is run. In the do loop, the condition isn't asked for until after the code is run the first time. That's the only difference. Well, the only major difference. And here you go. This is an actual outlier of what it looks like. So it'll do this loop first. It'll do what's in this block first, and then it will check to see if counter is less than or equal to 10. It has its positives and negatives. So here's a UML activity diagram of the do while. So display the counter value, which is, it's running the code, by the way, inside the do block. Increment the control variable, and then check to see if the control variable is less than or equal to 10. If it isn't, do it again. If it is, we're done. The switch multiple selection statement performs different actions based on the value of an expression. So we're getting into one of my favorite control statements. Each action is associated with the value of a constant, integral expression, or a constant string expression that the expression may assume. Figure 6.9 contains blah, 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 blah. Okay, so we have a bunch of integer variables that have been instantiated and initialized at the beginning of the class gradebook. We also have a property called course name that's been initialized at the beginning of gradebook as well. And then we have a constructor for gradebook, public gradebook string name, and the course name that's being added to the gradebook when the class is constructed. We then have our display message method, which displays the message and the course name that was added in the constructor. Then it goes into the input grades method. There is no return values for any of these. It's just doing something. It doesn't return a value. So it starts off with two variables, integer grade and string input, and then prints a message. Please enter the integer grades in the range 0 to 10. Type Control-Z and press enter to terminate the input. And then it asks for the input. While input is not equal to null, grade equals convert dot and then the input. So it's taking the input from the user and converting it to a grade. Or, I'm sorry, assigning it to a grade as an integer. It then adds that to the total and increments the counter by 1. It then executes another function called increment letter grade counter. And then after it executes this method, it asks the user for another input. Let's talk about this, the execution of this method. So increment letter grade counter is being overloaded or with the argument grade, and grade is the value of the input that we added or that the user adds to this method. The switch statement then looks to see, or it determines which grade was entered, right? So the grade divided by 10 will get you what? Well, if there's only 10 grades being added, and grade is the overall value that was added to the loop, I'm going to assume that the grade is going to be calculated every time the loop runs. So case number 9, the grade is in the 90s. Case 10, the grade was in the hundreds. And then increment A count. And you can keep on going, obviously. Case 8, grade between 80 and 90, plus B count, plus C count, plus D count. There are integers at the beginning of this class that are being used to count the amount of A's, B's, C's, D's, and F's that this person is inputting. And the default is an F. Default just means everything else. So in an if statement, you have if, and then if you just want everything else, you say else. In a case statement, there is no else. It's called default. And typing to write is not easy. Default and else are synonymous. And then display grade report, which is pretty self-explanatory. I'm not going to go over it. We've probably gone over this before, but basically, if the grade counter is not 0, then calculate the average, display the average, the grade counter, and the total of the total grade value, and then display the amount of grades that they received based on the letters. And if no grades were entered, run the else statement that says you didn't enter any grades, so I can't do any calculations. The expression following keyword switch is called a switch expression, and the app attempts to match the value of the switch expression with one of the case labels. You are required to include a statement that terminates the case, such as break, return, or throw. The break statement causes program control to proceed with the first statement after the switch. If no match occurs, the statements after the default label execute. The Gradebook test app uses class Gradebook to process a set of grades. And here is the main, and display grade report. Input grades are now the new functions that were added, the new methods that were added and ran based on the instantiation of the Gradebook class into the variable myGradebook. And there you go. You see how very few F's can really bring you down. Figure 611 shows the UML activity diagram for the general switch statement. And here's a diagram. What happens is you have a sentinel here at the beginning. I want you to look at this variable, x. If the variable, and then match x to the case statement that contains x's value. So if x equaled a, then this case would run, and then that'd be it. If x equaled b, then this case would run, and that would be it. If x equals z, and so on and so forth, and so to the end of all time. Although each case and the default label in a switch can occur in any order, place the default label last for clarity. So the expression after the case can be only a constant integral expression or constant string expression. You can also use null and character constants, which represent the integer values of characters. The expression can also be a constant that contains a value which does not change for the entire app. The break statement causes the immediate exit from a statement. So break in a case statement says, okay, don't check anymore. If the case is true, then the break means don't check anything else, just go back and iterate again or exit me. If you put a break in a for loop, it'll break the for loop. It won't keep iterating through the for loop. If you put a break and a for each, it'll do the same thing. So in this case, if count equals 5, terminate the loop. And when you add a break statement, it's really called breaking out, or breaking out of a loop. And there's your answer. Broke out of a loop at count 5. The continue statement skips the remaining statements in the loop body and tests whether to proceed with the next iteration of the loop. In a for statement, the increment expression executes, then the app evaluates the loop continuation test. So, continue will skip the remaining code in this loop, right? So, if there was the code after the continue, so if count is equal to 5, continue, meaning don't run this next line, just go to the next loop. And notice that the number 5 was not added here. It just skipped it altogether. Some programmers feel that break and continue statements violate structured programming, since the same effects are achievable with structured programming techniques. These programmers prefer not to use break or continue statements. In switch statements or case statements, break is mandatory. You cannot write a switch statement without break. There's a tension between achieving quality of software engineering and achieving the best performing software. This is true. Often, one of these goals is achieved at the expense of the other. For all but the best performance-intensive situations, apply the following rule. So, please take note. First, make your code simple and correct. Then, make it fast, but only if necessary. True, to a fault. There's a happy medium between the two. Make it simple and fast. That is possible. Not easy, but it's possible. We're going to talk about logical operators now. And these are operators we've already referred to, but we're going to go over in a little bit more detail. So a conditional AND operator reads as follows. If gender equals the letter F and age is less than or equal to 65, greater than or equal to 65, increment the single senior female's variable by 1. I'll read that again. If gender equals the string F and age is greater than or equal to 65, increment the senior female's variable by 1. The combined condition is true. So, if the gender is not female, but the age is 65, this is a false statement. Both parameters must be met in order for the block to run. And you can write it like this as well, which I am prone to doing. The table in 614 shows all 4 possible combinations of false and true values for expression 1 and expression 2. Such tables are called truth tables, or truthy expressions. So a false and a false are a false. And this is expression 1 and expression 2. In order for this AND operator to be true, in order for this expression to be true, both expression 1 and expression 2 must be true. The OR operator is the opposite. So if semester average is greater than or equal to 90, or the final exam is greater than or equal to 90, say the student grade is A. Both of these don't have to be true when you use the OR operator. One or the other has to be true for this to be true. If both are false, then it is not true. But if one is true and the other is false, or if one is true and the other is true, then it's true. So, in this case, you can have 3 situations where it's true, and only 1 situation when it's false. Both expression 1 and expression 2 must be false in order for this OR operator to return a false value. The parts of an expression containing and or operators are evaluated only until it's known whether the condition is true or false. If gender is not equal to F, it is certain that the entire expression is false, and the evaluation stops. It will not continue to go. It'll say, oh, gender's F? Okay, boom, this is completely false. This feature is called short-circuit evaluation. It's a form of breaking. So in this case, and I'll erase this again for your essay, let's say gender is male. Let's say it's not female when it comes through. Well, it will never run age, because both of these have to be true in order for this expression to be true. If one is false, this expression is false. So it won't even waste its time going to the next part of the expression. In expressions using operator and, a condition, which we refer to as the dependent condition, may require another condition to be true for the evaluation of the dependent condition to be meaningful. In this case, the dependent condition should be placed after the other one, or an error might occur. For example, in the expression I doesn't equal 0, the second condition must appear after the first, or a divide by 0 error might occur. Now, why is that? Because we didn't check to see if I was 0 first. Remember, code runs from left to right. So in that case, it's going to look at the leftiest expression first, which is this expression. Let's say you ran this one first, but I equals 0, and you didn't check to see if it equaled 0. Well, what are you going to get? You're going to get undefined, because you can't divide by 0. So you must check to see if it's 0 first. If I equals 0, then this will never run. Remember, both of these have to be true in an AND operator for both of them to run, or for the block to run. The Boolean logical AND the Boolean logical inclusive OR operators do not perform short-circuit evaluations. So, if you try to do the Boolean logical, which is a true or false definitive, it will not stop when one is not really working for the other. So in this case, birthday equals false, or birthday equals true, or age is greater than or equal to 65. What this does is, even if birthday is false, it'll still try to look for the age. For clarity, avoid expressions with side effects and conditions. The side effects may appear clever, but they can make it harder to understand code and lead to subtle logic errors. What that's basically telling you is use the code for the way it's designed. Don't get too complicated. KISS. Keep it simple. Stupid. Or keep it stupid simple. In this case, always use, if I can draw, always use the double and the double or. A complex condition containing the Boolean logical exclusive or caret operator, also known as logical XOR operator, is true if and only if one of its operands is true and the other is false. Here's the truth operator, or the truth table for the OR operator. And we already knew this, but if they're both false, then it's false. If they're both true, then it's false. It has to be one or the other. It can't be one and the other. What this means is it must be one or the other. In no world can it be either one is true or one is false. So what does bang mean? Bang means not, is not. It's a logical negation operator that enables you to reverse the meaning of a condition. If grade equals sentinel value, or if is not grade equals sentinel value, or if is not, this is quite redundant actually, because you could do it this way and say grade is not, if grade is not sentinel value. Now, when would we use the bang operator? We would use the bang operator when we want to check to see if something is null, or if we want to check to see if something exists. Now, of course, in C#, we don't use bang operators to check if things are null or don't exist if they're specific objects. For instance, if we want to check to see if a string is null, there's a function or a method called isNullOrEmpty. But if I want to check to see if something actually exists, I would actually write it like this. If persons Now, obviously, this can't be applied to persons because the is not persons actually does exist. But let's see, what can I apply it to? Let's create something. Like I said, this gets quite interesting because C# actually is coded in such a way that to disallow this from happening now. But all right, in JavaScript you can do it that way though. Ignore what I just wrote there. Oh no, actually, so if you wanted to check to see if a string has a value, you would say string dot is null or empty x, and it would check to see if x is null or empty. But you can't use a locally assigned variable, so I would have to take this out and put it somewhere else. No, actually, I would need to assign a value to it, which means that it will never be null or empty, because you can't have a local variable that wasn't initialized with a specific value. So that's quite redundant. And here we go. Logical negation. That's pretty self-explanatory. And here we go. We're creating truth tables here, but I'm not going to go over it. We've already gone over this already enough. So, C# operators with the highest precedence to the lowest precedence. PIM-, remember? And if you wanted to perform operations on operators that were a part of a string of operators, which I highly advise you not to do without parentheses, these are the high orders of precedence from highest to lowest using associativity. I'm not going to go over them, but if you want to, you can. Structured programming produces apps that are easier to understand, test, and debug. The final state of one control statement is connected to the initial state of the next. We call this control statement stacking. And this is the way it would look in a UML diagram. Once again, this is something that we've gone over already, but we can go over it one more time. This if statement will run, and then this if else statement will run. Enough said. So, for repetition, you have a while statement, you have a do while statement, and you have a for statement. And they all do their part to do specific things. So rules for forming structured apps. Begin with the simplest activity diagram. Any action state can be replaced by two action states in sequence. Any action state can be replaced by any control statements, sequence of actions that states if else, switch, while, do while, for, or for each, which I've already spoken about but does exist in Chapter 8. Rules 2 and 3 can be applied as often as necessary in any order. So, now they're going to go over a structured programming summary, and we're just going to blaze through this because we've actually gone over a majority of what we needed to go over for this chapter. So, simplest activity diagram, start, action, end. Rule 2 generates a stack of control statements. So we'll call Rule 2 the stacking rule. So it's going to add all of our control statements that we need. So Rule 2 applies, Rule 2 applies, Rule 2 applies. As different action states with control statements like ifs or if-elses or whatever the case may be. Rule 3 is called the nesting rule, which means that Rule 3 to the simplest activity diagram results in an activity diagram that neatly nested control statements. And here you go. Apply Rule 3 to nested control statements within specific blocks. So you'll have a for loop, right? And in that for loop, you might have an if statement or a case statement or whatever the case may be. You might have a do while loop with a for loop in it. Heck, you might even have a for each with another for each in it. That's actually not out of the ordinary. Control statements can contain a slew of other control statements, and this is completely normal. Rule 4 generates larger, more involved, and more deeply nested statements. If the rules are followed, an unstructured activity diagram, like the one in Figure 6.25, cannot be created. And here we go. We have an action statement that executes another action statement. And then we have an action statement that actually looks at a decision structure to see if it meets that decision structure, and then it can go back into this action statement over and over again until this action statement is satisfied and it exits out to the last action statement. This is an unstructured activity diagram, and it's actually really confusing, as you can see by all the red ticker tape that I just put in there. And that's it. That is it. We ended it on that note. Interesting. Well, this was a lot of slides, but there was a lot of information in this chapter that kind of surmised the control statements. What am I looking for? What word am I looking for here? The essence of control statements. But in this chapter, we talked a lot about control statements, but I actually showed you some real-world examples of how a control statement would be used and how we can actually push the use of control statements a little better. So I hope this was informational and it worked out for you. And if you need anything, just reach out. Otherwise, ciao.